I want to talk about what it actually means to limit the temperature increase to 1.5 degrees above pre-industrial levels. I'll talk about some of the implications of allowing warming to go above 1.5 degrees that we considered in the IPCC report, the Intergovernmental Panel on Climate Change report on 1.5 degrees, which really catapulted me into this debate when I was one of the coordinating lead authors of that report back in 2018. And, you know, I'll come back to this narrative of deadlines and how deadlines are important. They can be useful for people, but they can also be quite dangerous. And we need to understand what's happening and what it all means. But first of all, you know, we live in interesting times, and thanks to John for help with getting the data read in last night for this plot. I gave the last Gresham lecture, the seventh in the series, in September of this year. You probably heard September was you probably noticed it was a pretty warm month in the UK. It was also a very warm month globally. There it is at the end of that series. It was the hottest month recorded relative to the average for that month over the past 150 years. And, but you can see, and there was a lot of talk at the time of, you know, does this mean climate has crossed a threshold or something? But we have a big El Nino going on in the Pacific at the moment. And the last time we had a big El Nino in the Pacific was in 2016. And you can see that we had a big spike in global temperatures back then. And that what happened in September was more or less what we'd have expected to be when the next big El Nino came along. Now, what was different was that in the last El Nino, the really high temperatures didn't happen until January, February. So we're watching what happens in this El Nino, and we may see higher temperatures yet. But what is striking about it is that, you know, in many ways, what's perhaps slightly disheartening about it is quite how predictable what's going on is. I mean, we kind of knew the next big El Nino was going to be, if it happened 8 years after the last one, which is what's happened, was going to be a couple of tenths of a degree warmer, because that's the speed with which the world is warming at the moment, and that's exactly what we've seen. And of course, when we and what's happening in the world has not gone unnoticed. And if we look back to 2019, I love this picture because it's such an inspiring picture. And I don't know if anybody here in the room was out on these demonstrations in 2019, the school strikes, and one of the big headlines of the school strike movement was we got 12 years left. And that came directly from the IPCC 1.5 degrees report, which I was involved in. And I'll talk a little bit about where that narrative, you can see this, you know, the banner 12 years was very prominent in that, in those school strikes. And I spent a lot of time during 2019, that summer, going to the school strikes. Actually, I was wearing, a colleague had some T-shirts printed up. I'm a climate scientist, ask me a question. So we wore these T-shirts and went down to the school strikes. And one of the best interactions I had was, I was sitting on the tube on my way to the school strikes in Trafalgar Square, and a sort of elderly gentleman was sort of looking at me slightly quizzically, sitting opposite. And I was wearing, I had a jacket on. I thought it was quite hot, and I took my jacket off, and I thought, okay, here we go, what's going to happen? And he said, do you mind if I'm going to ask you a question in a very sort of like, and I thought, okay, here we go. But it turned out actually he was heavily involved in sustainability himself, and this is what he did. And he actually asked me quite a technical question about climate change solutions. So you should never judge a book by its cover. But anyway, back to 2019 and the 12-year deadline, which was all over the place. We had school strikes all over the world, led by Greta Thunberg, and I love that picture of Greta Thunberg giving the death stare to Donald Trump. And you know, the origin of this was just a few years earlier. We had the Article 2 of the Paris Agreement, which introduced, much to everybody's surprise, this target of holding the increase of increase of global mean temperature above pre-industrial to well below 2 degrees, and pursuing efforts to limit the warming to 1.5 degrees. That was the wording they agreed on in Paris. And I say much to everybody's surprise, it definitely took me and most of the academic community by surprise, because up until that time, the target was basically 2 degrees. 2 degrees was considered a good result. And that was what they agreed back in, well, they sort of started to agree it in Copenhagen in 2009, but then Copenhagen rather fell to bits, and then they reconvened in Durban the following year, and they managed to agree on 2 degrees as the goal. And a lot of countries were very unhappy with 2 degrees being the goal. They saw, that they were going to suffer a lot from a 2 degree of warming, and were pursuing this, and consistently pursuing an agenda to ratchet up the ambition of the UN process to 1.5 degrees. And they secured this in Paris. And as I say, it caught the academic community by surprise. Perhaps it shouldn't have done, because if we'd have been sort of more engaged with the negotiations, we'd have known what was going on. But we didn't. It also, put us on our mettle straight away, because one of the first things that happened was that as a condition, I believe, of agreeing to the 1.5 degree goal going into the Paris Agreement, the countries who were rather skeptical about 1.5 degrees insisted that they commission a report from the Intergovernmental Panel on Climate Change on 1.5 degrees to answer 2 questions. What difference would it make limiting warming to 1.5 degrees versus allowing it to go to 2? And was it even possible? Those are the sort of 2 key questions for this report. And as I say, I was one of the authors dragged in to do this. And we had to do this. The rules of the Intergovernmental Panel on Climate Change is you don't do research. The Intergovernmental Panel on Climate Change doesn't do research. It assesses the academic literature, which was a challenge at the time in sort of early 2016 when it was announced that they were going to require this report done in a couple of years, because there was no academic literature on 1.5 degrees. Nobody had ever bothered to consider the possibility that we might limit warming to 1.5 degrees. I mean, it makes us sound very bad and callous, but that's what the academic community had done. So we all worked pretty hard, actually, and it was a pretty frenetic couple of years.
The Gresham College lecture that you're listening to right now is giving you knowledge and insight from one of the world's leading academic experts. Making it takes a lot of time, but because we want to encourage a love of learning, we think it's well worth it. We never make you pay for lectures, although donations are needed. All we ask in return is this: send a link to this lecture to someone you think would benefit, and if you haven't already, click the follow or subscribe button from wherever you're listening right now. Now, let's get back to the lecture.
Oxford actually played quite a big role in this. We convened a conference. It so happened we had a conference booked for September the following year, and we just sort of, as soon as the Paris result landed, we just, I ran into my unit director and said, look, we're just going to rebrand the conference and make it about 1.5 degrees. And it was a very successful conference. We got a lot of people together, and we got a lot of academic journals involved as well to help produce special issues, to get peer-reviewed literature out there so that people can understand what the implications were of 1.5 degrees. And so anyway, we got the report done in 2018, and the headline in The Guardian when it came out, we got 12 years to limit climate change catastrophe, warns UN, and that was really the origin of the 12-year deadline. And the deadline narrative continues. The Guardian loves it. This was 4 years later, world close to irreversible climate breakdown. 5 years later, this is this year, climate crisis, carbon emissions budget is now tiny, scientists say. The UNEP, the United Nations Environment Programme, releases an annual emission gap report where they look at how well or badly we're doing at achieving our climate goals. It landed this morning, and this was the cover. I think it's a pretty unfortunate title, really, they've chosen for it this year, because, broken record. Yes, lots of weather records are being broken. That's the sort of, but it's also the whole deadline narrative is starting to sound a bit like a broken record as well. I mean, we're keeping on saying the same thing, and the same thing's happening, and I worry about whether this deadline narrative is really working for people. It doesn't seem to be. And is it potentially doing some harm? And I think maybe we'll come on to that in the questions. So, how people reacted back in 2019 was very interesting. We kicked off the school strikes, of course. Here's a tweet from a millennial saying, if you can't read it from the back, Tom Elliott is saying, we're like, millennials are saying, we're like the world is going to end in 12 years if we don't address climate change. And Alexandria Ocasio-Cortez, who's a progressive Democrat in the US Congress, picked up on this and pointed out, the UN says we've got 12 years left to fix climate change, and it gave a link to the Guardian article there. So that was the reaction, and of course there was inevitably a backlash. Of course, the backlash was strongest in the US because, well, everything's bigger in the US. So here's some energy website saying, let's break down the alarmist talking points fueling these kids' climate strikes. More specifically, a chap called Bjorn Lomborg, who's quite prominent in these arguments, popped up to say, wait a minute, the UN estimates that climate change by the end of the century will be equivalent to an income loss of 2 to 4% of GDP. He loves saying this and loves pointing out, well, that would only be like a couple of years' growth. So we're sort of deferring the wealth we'll be at in 2100 to 2102, so what? And these are the estimates he quotes for those in support of this from various studies, and we'll come back to that because I think this whole question of what difference does it make allowing warming to go beyond 1.5 degrees is really the crux of this lecture. But I would like to spend a little bit of time, because it was my job on that 1.5 degrees report, to talk to you a little bit about what reaching 1.5 degrees actually means. I should have pointed out that squiggly line that I plotted last night with John's help, we've already had a month well over 1.5 degrees. In fact, I believe yesterday or 2 days ago, there was a daily temperature which was close up to 2 degrees. I mean, we're getting, if you take a short enough time scale, we're seeing fluctuations that are well up there. But that's not what we meant, or not what the Paris Agreement meant either, by temperatures reaching 1.5 degrees. It's the warming, the underlying warming that we're talking about, which is shown in this figure by that orange line. The orange line here shows you the human-induced warming. We spent some time in the last lecture talking about how we estimate the human-induced warming. That's a human contribution to the warming. And if we carry on that warming at the current rate, then we would reach we estimated back in 2018 that we'd reach 1.5 degrees sometime around 2040 with a range of uncertainty, sometime between 2030 and early in the 2050s. So the Guardian looked, and others, of course, took that range, looked at, okay, we might get to 1.5 degrees as early as 2030, and that was the origin of the sort of 2030 headline that was fed on into the 12-year narrative. Well, you can immediately see, okay, it's looking at that graph, you wouldn't say we were only 12 years away from climate disaster, but clearly the impacts are getting worse as the world warms, and we'll come back to that in a minute. But first of all, we've got to talk a little bit about what it actually means to reach 1.5 degrees. What does it mean for the climate to reach 1.5 degrees? Because when you're in a warming world, the traditional definition of climate that we used to use when I was a graduate student in the 90s, it sort of worked back then. It was the World Meteorological Organization defines the climate as the average over a 30-year period. That's the sort of standard definition of weather, of average weather. And they insist on a 30-year period so that you can average out all the fluctuations and get a handle on what the weather's normally like. But of course, if the world's warming, if you think about if the average over the most recent available 30 years is always going to be misleading. It'll always be, if the world's warming at 0.2 degrees per decade, then it would be 0.3 degrees too cold. Did I get that right, more or less? I think so. Somebody will correct me at the end. Okay, so, it's not warming at that over that period. It wasn't warming at quite 0.2 degrees per decade. So it's at the rates the world has been warming or had been warming up to 2018. If you'd just taken the average over the past 30 years, we'd have said that the world was, quarter of a degree cooler than it actually was. And that's sort of fairly obvious from this graph. But of course, this, when you're talking about something like temperatures reaching 1.5 degrees in the Paris Agreement, this all starts to get quite loaded because it's not just a scientific exercise to work it out. It actually has political and even legal, even financial ramifications. Lots of countries argue that the trigger for what they refer to as loss and damage payments should be when temperatures cross 1.5 degrees. Other countries strongly disagree. You can imagine which countries are which. But the point is, this has become a legal question when we reach 1.5 degrees. And so, actually, I spent a lot of my time with the Intergovernmental Panel on Climate Change report on this kind of rather arcane argument about what is the present-day climate. Do you think, what a completely stupid question? But it's not. It becomes quite complicated because the standard World Meteorological Organization definition would have always been 15 years out of date. And as a physicist, I would much prefer to say, well, the climate is the moments of the attractor of the weather. Everybody knows that. And if you're a physicist, that statement means something. And if you're not, it probably doesn't mean a huge amount. And certainly, I discovered if you're a lawyer, it means nothing at all. So what I mean is that if you allowed the weather to evolve many, many times with the same drivers, and then took a distribution over the possible states that you found, and took the average, that would be the climate. But that was regarded as too esoteric a definition of present-day climate for the UN purposes. So we ended up with a definition of the temperature this year as the temperature we would find if we were able to take a 30-year average with the middle of the 30 years in this year, assuming whatever trend that's happening were to continue. Okay? So that's where we landed eventually as a sort of bit of a compromise. And actually one of the reasons I spent a lot of time worrying about this is illustrated by this next figure. So we talked about these in the previous lecture. There's sort of multiple things driving climate on interannual timescales. The trend is overwhelmingly driven by anthropogenic human-induced increases in greenhouse gases. But every now and then you can see here this blue lines. That's the contribution of natural variability to global temperatures. And those dips are associated, those are volcanoes. They're the cooling effect of volcanoes. We'll come back to them in a minute. But there was, during 2018, we had this very tight deadline for producing this IPCC report. We knew that there was no opportunity for slippage because it was sort of fitted into the whole UNFCCC negotiation process. And all the meantime, there were rumors of a volcano rumbling on in Java. And everybody was saying, oh, it's going to blow. It's going to be another big one, just like that one. And I was completely convinced that a matter of months before our final report landed, and by the way, these reports are reviewed in painstaking detail. So once it's sort of rolling, it really is set in stone several months before the final acceptance date. And so if this volcano had gone off and then cooled the whole planet down by a couple of tenths of a degree, it would have been a total nightmare if we hadn't landed the point that the present day temperature is not what we're talking about. It's this, background 30-year, this background trend with the 30-year average accounting for the underlying trend. So that's what we established. We managed to get that nailed down, and we, in fact, use the apparatus that I described to you in the previous lecture of attributing temperature changes to different drivers to work out not just a trend, but how much of the trend is due to human influence. And that allows us to pull out that orange line, which is the expected response to anthropogenic, to human factors, which allows us to, and with some uncertainty on that, to say where warming had got to. So the formal definition of where the warming has got to is where human-induced warming has got to, or where this average over a 30-year timescale has got to, accounting for the human-induced trend and also removing the impact of any volcano if it had gone off. And as it happened, we were lucky and the volcano didn't go off. In a sense, I was a little disappointed because we'd done all this prep so that if the volcano had gone off, it wouldn't have scuppered the report. But anyway, it didn't. So it was all, various colleagues thought I was being completely unnecessarily pedantic throughout. But anyway, they would have been grateful if it had gone off. That was what Anyway, so this is how we work out. This is how we work out the current level of warming, and that's what we're sort of heading towards. And if you compare that to those decadal averages that I showed you earlier on, the sort of WMO definition of averages over 30 years, you can see that since the 1960s or so, most of the warming we've seen all of the warming we've seen really is due to human influence, which was the conclusion we talked about in the previous lecture about how it's extremely likely that human influence has been the dominant cause of the observed warming since the mid-20th century. So that's just to connect up this with the previous lecture. On this basis, we reached 1 degree in 2017, and on that rate, we also reached on the basis of this record, we reached 1 degree in 2017. Also on the basis of this record, this was the record that was available to us at the time, back in 2017. The record was also consistent with the statement that at the time they were negotiating the Paris Agreement, the negotiators were told the world had reached 0.85 degrees of warming. So that was the information that was provided to the negotiators when they were arguing over what they were going to agree in Paris. They had a very formal system called a structured expert dialogue, where experts from the Intergovernmental Panel on Climate Change gave presentations to governments, and this was the number that they gave them. And the current level of warming was deemed to be 0.85 degrees above pre-industrial levels, and that is indeed roughly the temperature of the decade or decade and a half or so prior to 2015. By coincidence, conveniently, that happened to be a period where global temperatures were quite stable. In fact, you probably can remember the Daily Telegraph would publish a headline saying global warming stopped in 2000, quite frequently. They stopped doing that. In fact, there's an outfit called the Global Warming Policy Foundation, which various, it keeps being revealed, different conservative politicians are members of it. But they used to have as their logo global temperature over the 21st century, because it was impressively flat. But they've actually abandoned that logo and moved to a much more neutral logo, I noticed recently, because obviously it sort of doesn't really work for them anymore. Anyway, interesting that. I bet I'll get some emails about that afterwards. There we are, never mind. Hello, everybody. What that means, with that record, at that rate, it implies we'll reach 1.5 degrees around 2040. However, and there's, of course, a range of uncertainty around that. But the record, of course, is uncertain. What has actually happened in the past? And here's a bunch of estimates, different estimates, you'll notice they are slightly different from each other, of global temperatures over the past century. And we haven't talked very much about observations in these lectures so far, so it's important to recognize that this, if I show you a plot of global temperature, there's a lot has gone into it. If you stop and think about it, how on earth do people know what's happened to climate over the past century? And the fact is that there's a huge science in this, in gathering together observations from all over the world, and particularly when you go back to the 19th century to get that baseline that we're measuring against. Large parts of the world, like the Pacific, are barely observed because the only observing network they had back then was merchant ships. And the Royal Navy, in fact, played a big role in this. I think it was part of ruling the waves was you measured their temperature. It seemed to be a sort of fairly standard thing they did. But they did it using, and there's an interesting sort of digression here, but there's a remarkable role of this wooden bucket in the history of climate science, or these buckets like it, because Royal Navy ships used to use these standard wooden buckets, chuck them over the side, pull it up, dip a thermometer in, and then record the temperature. And then they switched, but that was a very heavy wooden bucket, and so they switched in the sort of, they modernized the system to that canvas bucket, okay? But the problem with the canvas bucket is that it's canvas, wet canvas, being dragged up the side of a ship in a howling gale is going to cool off. And that's exactly what you see happening. Wooden buckets, suddenly they introduced canvas buckets, and it got a whole lot colder. The world got colder, apparently. And then they realized that the canvas buckets weren't very reliable, so they introduced these modern insulated rubber buckets, okay? And the world warmed by 0.5 degree. Boom, okay? So, now, fortunately, they've kept all these gadgets, and, people like David Parker spent an admirable amount of time chucking them over the sides of ships in various different weather conditions to work out. So this fortunately, because we've kept all not just the records, but how the records were made, it's possible to correct for these things and to gather this data together and establish what actually happened. But as you might imagine, these corrections, and in particular, the method you use to fill in the gaps in a record going back over a century, do affect the outcome. They do affect the estimate you end up with a little bit, not massively so, but enough. And as the record gets updated, so here was the record that we were using. It's now been updated in 2021, and you'll notice the impact of the update is to make it a little bit warmer today. But of course, if you stop and think about it, wait a minute, today didn't change. What changed was the estimate of what temperatures were back in the 19th century, because we concluded that the global temperature in the 19th century was about 1/10 of a degree cooler than we thought previously, which of course means that 2017 was over 1.1 degree warmer than pre-industrial, the 2006 to 2015 period, which was 0.85 degrees warmer than pre-industrial, according to the people informing the Paris Agreement, was actually closer to 1 degree warmer. So what do we do with all this information? Because what that implies is that we'll reach 1.5 degrees not in 2040, but in the early 2030s. And that's where you get to with a certain range of uncertainty. And of course, cue more headlines from The Guardian about how close we are to disaster. But what's actually changed here? We've changed what we think the temperature was in the 19th century. That doesn't make any difference whatsoever to what's happening today. But of course, it matters because the governments have agreed that they want to limit warming to 1.5 degrees above pre-industrial. And, if we got it wrong, we got it wrong. And, that means that we're going to get to 1.5 degrees earlier. But But what this should tell you is sometimes when you read the headlines, you might think that something very dramatic is going to happen exactly when we reach 1.5 degrees. And I'm telling you this little anecdote because it shows that it's even what 1.5 degrees means is vague to within a tenth or two of a degree. Because, what we thought 1.5 degrees meant back when we were negotiating the Paris Agreement is slightly different from what we think it means now. And of course, what does pre-industrial mean, even? And again, I'm not trying to send the message, oh, we don't know anything. No, but I'm just pointing out that at the sort of tenth of a degree level, there is a certain amount of conventionality, should we say at least, about this. You've got to kind of agree what pre-industrial means. Because you could argue as long as you liked about what is pre-industrial, and this is an estimate of global temperature going all the way back to the year naught of the Common Era. And you can see that there was a gentle decline, and again, it's important to stress, if buckets were an issue for this part, when you go back beyond even the invention of the thermometer, you can imagine the uncertainties in constructing a record of global temperature all the way back there. There's all sorts of things get used: pollen, tree ring, ice cores, and so on. But it's an art. It's detective work. It's not something you've gone and actually measured. So, but it is believed that there's been this very gradual decline of a couple of tenths of a degree over the past 1,000 years. And indeed, in this, when you're choosing a period to regard as pre-industrial to measure 1.5 degrees against, you've got to make a decision. And they used this period in the late 19th century, 1850 to 1900. We actually had quite a lot of argument about that then, because the physical climate scientists, people like myself, preferred a 20-year period, 1860 to 80, because it excluded something very dramatic that happened in 1883, which was the eruption of Mount Pinatubo. Mount Pinatubo was the recent one. Krakatoa was an even bigger eruption, which occurred in 1883, and an island in Indonesia blew up, and it put so much material into the stratosphere, it cooled the planet significantly, and gave lots of material to Turner to paint his sunsets. These were the origins of the Turner, those very dramatic sunsets that Turner saw, because this material passed all the way around the world and produced these several years of very, very dramatic red sunsets. But also, cooled the planet. Of course, that, should we include Krakatoa in the period that defined pre-industrial? And we had long arguments about this. I lost that argument, so it was included. It didn't make that much difference. But you can see the sort of decisions that have to be made here in defining where we're starting from. But more importantly, I promised we'd come back to this about how it matters, how it matters. Not so much. Yes, it matters to lawyers when exactly we reach 1.5 degrees, because they love to be pedantic about these things. But for the rest of us, what matters is how much every incremental amount of warming we see is how much harm it's doing. And I talked about this backlash that happened after the original 1.5 degrees report landed, and we had all these headlines about 12-year deadline. And Bjorn Lomborg, indeed, was tweeting this with a figure showing estimates of damage as a function of global temperature. And one thing you'll notice is that, he claims that, 3 degrees of warming is an income loss of about 3% of GDP, a couple of years of growth. Now, those numbers are highly contestable, and I'm going to contest them in a minute, but at least we can agree on the overall shape. So Bjorn Lomborg and I agree that the shape of the damage function is, it starts off pretty flat and then gets steeper. And that sort of makes sense, because as we move away from the familiar climate that our ecosystems and our economy and so on have been adapted to, we expect the impact of every additional tenth of a degree of warming to be worse than the last one. Why do we expect that? Because just ask yourself what would happen if we went away in the other direction. That would also cause harm. Cooling the planet would cause harm because we're adapted to that. We're adapted to that point in the middle where civilization, if you like, developed. And so the simplest shape we could adopt is what we call a quadratic. That's a sort of a temperature squared curve, okay? And again, physicists love to do this kind of thing. On a small enough scale, everything's a quadratic, if it's not a straight line, yeah? I mean, if you, okay, sorry, in jokes, I suppose. But anyway, but the point is, therefore, for small enough warming, you should expect to see this kind of shape, which means that if, according to Bjorn Lomborg, 3 degrees of warming costs 2 to 4% of GDP, then 6 degrees of warming would cause a loss of, around 10% of GDP. And of course, conversely, as you go to the other side, 6 degrees of cooling should cost sort of 8 to 10% of GDP. Well, I don't know, but I think 6 degrees of cooling would probably cost a little bit more than 10% of gross domestic product. We have experienced that in the past, and it sucked for the humans that were around at the time. So in fact, we've done quite a lot of work. One of the things we did for the 1.5 degrees report was, in fact, a study of the economic impact of 1.5 degrees of warming versus 2 degrees, versus the present day and versus 2 degrees, using not the kind of back-of-the-envelope estimates that Bjorn Lomborg was using, but actually using data of how growth, observed growth in the economies of different countries responds to variations in global temperature. And Felix Pretis led this study. It was a very elaborate statistical study because, of course, he had to take into account all the other things that were going on, like wars and global economic growth and so on. But he was able to tease out a temperature impact with a lot of uncertainty in it. It's important to stress, so there's large uncertainty bars there. But he was able to identify not just the global impact of a further half a degree of warming above where we'd reached, but also the impact on how this affects different countries individually. And as we go to 2 degrees, you can see all the purple countries here are the ones that are being adversely affected by 2 degrees of warming relative to the present. And you can see where they all are, predictably enough. These are the big countries in the these are countries in the tropics that are vulnerable to a little bit more additional warming because a lot of, they're sensitive to the heat stress and the additional burden on their economies that will result from any warming. You'll notice a couple of green countries are appearing here. These are countries who, according to the data, this was just a purely data-driven study, and there was a bit of squeamishness about this. We said, no, we published the results. And these are countries where, according to the data, there would be a small benefit from a further degree of warming above the present. And we could also show who benefited and who lost out from limiting warming to 1.5 degrees versus allowing it to go to 2. And the key point here was that nobody benefited significantly from allowing temperatures to go above 1.5 to 2, but several countries significantly lost out from that. And we could, able to sort of identify these countries, and there's a big table of them. And the ones at the bottom of the table, just to sort of illustrate the countries that are most vulnerable to this additional warming, are, Saudi Arabia, Mauritania, Djibouti, Bangladesh. You may be slightly surprised to see Saudi Arabia on that list, but of course this is about the impacts of the warming, not the impacts of the process that causes the warming. So, and up at the top, cold countries like Russia, Canada, Mongolia, and so on. So one of the key things which comes out of this, of course, is that the impacts of warming are very, very different depending on which country you're in, or sort of what your position is, and how much warming costs you depends very much on who you are and where you live. Which is why in 2018, we said very firmly that one of the questions that we were being asked by the governments, we refused to answer it. They were basically asking us, is it worth it, limiting warming to 1.5 degrees? And we said any comparison between 1.5 and higher levels of warming implies a risk assessment and value judgments that we can't reduce to a cost-benefit analysis. This is the kind of thing that the Treasury loves to do, comparing cost of a policy with benefits of it and working out if it's worth it. Interestingly, in 2023, the Intergovernmental Panel on Climate Change really stuck its neck out on this and actually said the global economic and social benefits of limiting global warming to 2 degrees exceed the cost of mitigation in most of the assessed literature. And the reason I was very surprised to see that statement in the sixth assessment report, which came out a couple of years ago, was they don't make the same statement about 1.5 degrees. Because so they were implicitly acknowledging, they actually have a footnote that explicitly acknowledges that they can't make the same claim about 1.5 degrees. So does that mean, and it's sort of, someone could read this, oh, well, it's not even worth it. Economically, it's not worth even trying to limit warming to 1.5 degrees. So, but I mean, the crucial issue that emerges here is that how much globally you regard a warming of 2 degrees versus 1.5 degrees to cost depends critically on how much you weight impacts on Congo to impacts on Canada. And if you just add up dollar impacts, you often find the impacts on Canada are much more valuable than the impacts on Congo, because Congo didn't have much money in the first place. So, you take 10% off their economy, well, it wasn't great in the first place, so it's not very much money in the end. Whereas, a couple of percent benefit to Canada is a big impact on global GDP. But clearly, thank you very much, that's great. One of the crucial things which comes out in this is that climate change costs lives. And if you want to add up the cost of climate change, you may not be explicit about it, but you need implicitly to assign a statistical value to a life. And back in 1995, the Intergovernmental Panel on Climate Change actually did this exercise, a sort of cost-benefit analysis, and they did what was standard at the time, which was you assign a value to a life according to what somebody is willing to pay to prolong their life. And you look at the statistics of different countries and work it out. But of course, that's not a function of what the life's worth, it's a function of what the person's able to pay. And as a result, it sort of emerged in the course of producing the 1995 report that they were effectively weighting the life of a Bangladeshi at some tiny fraction of the life of a resident of Florida. And there was a huge row, and that entire section of the report got ditched, I think rightly so. And the IPCC, the Intergovernmental Panel on Climate Change, has been very squeamish about coming back into that arena ever since, and I think correctly so. So I was very surprised when they ventured back into this in the last report. You'll notice that their comment is not about a judgment of the IPCC; it's just a comment about the literature, and so it's appropriately cautious. But it's a problem trying to assign value to different levels of warming in the way that people like Bjorn Lomborg and a lot of the community saying, it's not really worth it trying to do anything about climate change, because let's face it, it's not going to do very much harm anyway. In order to say how much harm climate change is doing, they have to add up impacts in this way. And they have to make decisions about things like the statistical value of life. Are poor lives worth less than rich ones? Social impacts. A mass movement of people from a part of the world made uninhabitable by rising temperatures, which might be a poor part of the world, to a rich part of the world, would probably increase global GDP. Yeah, once everybody moved, they then sort of get much closer to, automatically get much closer to the income levels of the country of their destination, and on average, the world would be richer. But you can just imagine the social disruption that might accompany that. Anybody listening who's worried about small boats? There you go. I mean, these are not cost-free disruptions. And also, there's, for the Streatham College, Streatham School kids, there's a very important part of this, of course, is how do we weight impacts on the present-day generation to impacts on future generations. And again, that's a crucial element in deciding what the value is of different levels of warming. So what I think we can't do this, assigning an absolute value to global climate change. What we can do is say that it's roughly that shape. I think that's pretty safe, because everybody agrees on that. And in a sense, it sort of almost has to be. If we just accept that that was the climate we were adjusted to, we expect climate damage to get worse, and get worse faster as we move away from that pre-industrial condition. So whatever damage climate change is causing today, we could expect 2 degrees of warming. We're at 1.25 degrees now, so the damage we've experienced over the past decade is around sort of like 1 degree damage. Okay, so we could expect at 2 degrees 4 times as much damage. Just square the temperature. Yeah, 1.5 degrees, 2.25 times as much damage. Slightly harder sum, you can probably still do it in your head. 1.25 degrees, where we're at now, 1.6 times the damage. So what this tells you is, you don't have to agree with anybody about the absolute value of the damage, but the difference between 1.5 degrees and 2 degrees, that additional half a degree of warming, is going to do at least as much damage as all the climate changes that's happened to date. Because we expect the damage to get steeper, the damage curve to get steeper as we move ahead. So that allows you to put it into context, and whatever you care about climate and what's happened already, you should care just that much and more about avoiding that additional half a degree of warming beyond 1.5 degrees. So I just want to wrap up by talking briefly about how not to think about warming by 2100, because you're going to hear lots of headlines about this during COP. This thermometer is a very beloved graphic that is flashed around a lot at COP. It's massively misleading because it implies that basically what it's about is warming to 2100. And it tells you that if we manage our 2030 targets, we'll limit warming to 2.4 degrees. And if we go much beyond that and include all the long-term pledges, we'll limit warming to 2 degrees. So you might think, well, that's a lot of work for 0.4 of a degree. Okay? What this is doing is actually leaving out the crucial point that what the numbers here they're talking about are only warming by 2100. They're not actually differentiating between conditions where we've actually stopped the warming in 2100 or situations where it's still carrying on warming. And this fixation on 2100 even started to creep into the negotiations in Glasgow, where they started talking about limiting warming to 1.5 degrees by 2100, as if that was the goal. And of course, if that were the goal, and it certainly wasn't the goal agreed in Paris, you then would never know whether you'd met it or not until into the 22nd century. Because if the goal was limiting warming to 1.5 degrees by 2100, you wouldn't know until 2010 whether you'd succeeded or not, 2110, and whether you'd succeeded or not. So, this obviously would have huge ramifications for things like loss and damage, because then people will say, well, we don't know if we made it or not, even though temperatures might be at 2.5 degrees, but, we may be, on our way back down to 1.5 degrees by 2100, who knows? So that's, fortunately, that was got rid of very quickly from the draft decision text. But this way of thinking hasn't gone away. In the press release that accompanied the UNEP GAP report that landed this morning, we see this current targets, basically, would lead to temperatures not exceeding 2.5 degrees above pre-industrial levels. No, current targets would return the current rate of warming from roughly 0.25 degree per decade, which it is at the moment, to about 0.17 degrees per decade. So reduce it by about a third or so. And then if you work it out, that gets you to 2.5 degrees by 2100. So it lowers the rate of warming slightly, but it's still warming. So it doesn't limit warming to 2.5 degrees at all. It just means, instead of getting 2.7 degrees by carrying on at the current rate, you get 2.5 degrees. So it's they didn't, in the press release, they didn't even mention 2100 at all. So this is very dangerous rhetoric. Okay, back to what 1.5 degrees actually means. The right way to think about it is there's a lot of sort of bogus precision bandied around at these COPs. 2.7 degrees versus 2.4 degrees. Really? We don't know these. So you mustn't let yourself be distracted by this bogus precision. 1.5 degrees is a milestone. It's important when we pass a milestone to note that if we do pass the milestone, we hope we won't pass it, but if we do pass the milestone, you shouldn't expect anything dramatic to happen just because you pass the milestone, but it does tell you the direction of travel. And indeed, it's actually quite a good analogy, the sort of 24 miles to London. What does it mean, 24 miles to London? I mean, London's, how many miles across? So you have to choose rather specifically one bit of London as the place you're going to measure stuff from. It's Charing Cross or something, isn't it? I can't remember. Anyway, but the point is it's a convention. And the same goes really for global temperature. We had to sort of agree what pre-industrial was. And so therefore, there's no sort of nothing absolute that's going to happen. But just to, remember, as we approach this COP, remember this analogy that I gave you early on in these lectures. If we hit the brakes now and manage to stop warming by mid-century, we would limit future warming, all future warming, to less than what's already happened this century. I think, if you remember that, doesn't mean it's not a big deal. Adding on the same amount of warming again that we've already had since 2000 will cause a lot of harm. But if we manage to do that, we'll avoid a lot of harm as well. And that would be a huge result. And, I think we need that, which is why this coming COP in Dubai is so important, because we are finally starting to talk about the kind of things we need to do to actually stop fossil fuels from causing global warming by mid-century. So things to look for in the outcome of COP28. Will we agree to phase out all unabated use of fossil fuels at this COP? That's the phrase to look for in the findings. Then, of course, we've got to agree on what abated use means, and we better agree that it means something that's compatible with the Paris Agreement, meaning permanent storage of all the CO2 generated. And then, of course, we've got to get on with it and phase up the fraction of carbon dioxide that is safely and permanently disposed of at the same time as we phase down total fossil fuel use. And this is one sort of good bit of news coming out of this COP, because it's really important to emphasize the positives in the climate issue. There is a little reported development led by a motley crew, including the United States, Saudi Arabia, Canada, the United Kingdom even, which is committing to store a billion tons of carbon dioxide back into the Earth's crust by 2030. They're calling it the Carbon Management Challenge. And if you work out what this means, if they can maintain that rate of acceleration in driving up the fraction of carbon dioxide generated by the fossil fuels we use, that's re-injected back underground. If they can maintain that over the next 30 years, then we'll stop fossil fuels from causing global warming by the 2050s, which would be a huge result. And let's watch for that language, and watch for the Carbon Management Challenge, and watch for the countries that are joining in with it, where they're actually putting action where their words are. Anyway, to sum up, why 1.5 degree matter? Every 10th of a degree causes more harm than the last one. Warming, remember this, when people are saying warming from 1.5 degrees is not that harmful, well, warming from 1.5 degrees to 2 degrees is at least as harmful as the warming we've already experienced to date. But it is a milestone, not a cliff edge. There's no reason to believe that anything dramatic will happen when we get to 1.5 degrees, but it is the point at which we have agreed collectively that we're going to try and limit warming. So let's hope for a good outcome at COP28 and get us on the road to achieving that milestone, to stopping before we get to that milestone. Thank you. Sorry, I've got a bit close to time, but hopefully we've got enough time for a couple of questions. Thank you.
Professor Allen, thank you. That was a fascinating lecture. And yes, I think we will squeeze in a couple of questions if if we can. So the first one, there's quite a few, because a lot of the lecture covered elements of method, like how you come to these decisions. And so there's a few I'm going to sort of bunch them into one another. I'll have a go. So when you sort of, as you talked about with the economics, it was striking how you use a different model, a different baseline for calculation. You get quite wildly different models, which then produces very different results. But thinking about the science, when you said, you were the first sort of group of people that sat down and thought about 1.5, how do you start that? How do you go about getting, because science by its nature, it's all committed to truthfulness, we hope, we know, but so many different disparate sources, how do you bring them together into any sort of a unity to calculate from?
Yeah, there's a lot to it, a lot of discussion, and and it's very important that the process is as inclusive as possible. And one of the things, just to big up physics on this, yes, we have to make these decisions in the climate physics community, and they make differences of like 1/10 of a degree. The economists make decisions, and they make differences of like factors of 2 or 3, or more. So let's be clear where the uncertainties are, and it's not the economist's fault. It's just that that's where that's where a lot of the uncertainties lie. I think it is very important in doing our science to be clear what is sort of dictated by the world out there and what we're bringing to the problem in terms of our own preconceptions. So, for the physical science part, the argument about whether Krakatoa should count as representative of pre-industrial, okay, fortunately it didn't make that much difference, as I said, I lost that argument, it didn't really matter. But the argument about whether we should assign equal weight to a dollar lost to a Congolese to a dollar lost to a Canadian, that makes a huge amount of difference to the outcome of how you weight different levels of warming, or a dollar lost to a school child today when they're in their 80s compared to a dollar lost to a pensioner today who's already in their 80s, for example. I mean, these are, sorry, it's a feature of economics that everything's in dollars. I know, sorry about that. I do think one of the things we have to do is be very clear what's our preconceptions versus what's come from outside. The other thing we have to really work on is, and something that the whole climate science community is working on, is being more inclusive of different perspectives in the research process itself. Because, for a long time, climate science was very heavily dominated by people who looked like me, to be honest with you, and that's a problem because it's not really up to us to, pontificate to the world how they should behave.
Just on the costs, you describe them in a sort of quadratic, as though there is a smooth increment, and I'm just wondering, taking Krakatoa as an example on the other side, whether you see these costs as mainly incremental, or are there some big costs that come at various tipping points that need to be factored in?
We have a whole lecture on tipping points later this year, so come back for our lecture on tipping points, if that's a reasonable answer. I mean, it's but yes, but for these at the moment in our models for these small levels of warming, things seem to happen relatively smoothly. That doesn't mean that's true of the real world. And indeed, in the real world, things, when it comes down to impacts, particularly impacts on extreme weather, which we will be talking about in the next lecture, coming up in January, things do seem to be happening rather by fits and starts, and perhaps not as smoothly as we would have liked. So yeah, no, this is a big issue. But the difficulty we have is that if you can't predict when a jump will occur, it's almost like the uncertainty smooths it out. I mean, it's still there, but it's smoothed by uncertainty, if you see what I mean. Yeah? In the way in our thinking, if not in reality, and not in the experience of it. Okay, we'll get onto this in the tipping points lecture, if that sounded very mysterious to you. Okay, thank you very much.
And in the meantime, please join me in thanking our guest speaker tonight, Professor Myles Allen.